Here's a solution for day one, problem one. Rewrite this number into standard form. So we have a number in scientific notation, and this portion of it is 10 to the negative 8th power. Multiplying by 10 to the negative 8th power means to divide this number by 10 8 times. Every time you divide by 10, the decimal point will move one position to the left. So that is going to create point and then 7 zeros. 1, 2, 3, 4, 5, 6, 7, and then the 2051. So here is this scientific notation number written in standard form. Now question B, rewrite this number into scientific notation. Here's the decimal point right now in the number, but in scientific notation the decimal point always comes so that there's one digit to the left of the decimal point. We need to put it right here. So that means it needs to be moved 1, 2, 3, 4, 5 positions. That will create 2.3 and then times 10 to the negative 5th power. So on this one here, be careful that you need to use a negative exponent to represent this decimal number that's less than 1 unit. Now, day one, problem 2. Solve this equation and then check the answer. One way of doing this equation is to use the distributive property to remove these parentheses. 10 times a is 10a, and 10 times negative 1 is negative 10. Now we can remove the constant term by adding 10 underneath and on the other side to retain balance. So that's 10a equals 26. And then we can remove the coefficient of a using division. So divide by 10, divide by 10. 10a divided by 10 is 1a. And 26 divided by 10 is either a fraction or the decimal 2.6. Okay, here's the answer we think is correct for A. Let's substitute that and see if it makes the left side equal to the right side of the original equation. So fill in the 2.6 for the letter A. When that is filled in, does that make 16? So following the order of operations, in the parentheses first, 2.6 subtract 1 is 1.6. And then is 10 times 1.6 16? Yes, it is.